Hi guys, it's Miss Simon. So I wanted to make this video today to help you guys out with science. So remember we've been talking about contact and non-contact forces. And yesterday you watched an ed puzzle that started reviewing the third and final non-contact force that we are going to be talking about. And that is going to be gravity, okay? So I'm gonna go ahead and share my screen and get started. So remember if I highlight it, make sure you put it down in your notes. All right, so the third and final non-contact force that we're going to be talking about is gravity. So go ahead and put that down in your notes. So gravity, as you kind of learned yesterday from the ed puzzles, we know that gravity occurs when we let go of an object. It pulls the object down to Earth, okay? All right, so like we've been discussing, guys, there's contact forces and non-contact forces. What are the two non-contact forces that we've covered so far? So think back, what are the two other non-contact forces that we've covered so far? All right, if you said magnetism and electric, you are correct. Remember, those are our two other non-contact forces. Now we're going to talk about the third one, which, like we said, is gravity. So this force of gravity is probably the most familiar to you. If you were to hold an apple and let it go, which way would it go? So for example, if I have this highlighter and I let it go, it's going to be pulling down. It's going to fall down to Earth. You didn't have to throw it to make it move, okay? It just fell down. So since it wasn't moving and then it started moving, what had to be applied to it? Okay, well, what had to be applied to it was something that we know as gravity, okay? Nothing touched it for it to fall down, but it was pulled immediately down to Earth when you let go of the marker. The force that caused the apple to move is called gravitational force. Gravitational force has been studied since ancient times. Magnetic and electric forces, however, had to wait on the development of more complex measuring techniques and equipment. It wasn't until the 17th century when their secrets started to be revealed. So obviously gravity was discovered way before electric and magnetic forces. And that would make sense because we can clearly see that when we drop this, it falls to the ground. People will have noticed that years and years and years ago, okay? And they wanted to know why, because that was noticed by everybody. All right, so go ahead, gravitational force. Gravitational force has been studied since ancient times. So like we said, it's been studied since the way back, because obviously scientists and people could see that when they dropped something, it fell to the Earth and they wanted to know why. All right, moving on. Now, gravitational pull. Gravitational force occurs when two bodies physically attract each other by pulling, okay? So for example, we see this picture of a cow here. The cow jumps off the diving board. Initially, that we know, think about if you've ever jumped on a diving board. When the cow jumps, the cow is gonna go up, but the Earth immediately is going to pull that cow back down and it's going to splash in the water. So did you know that what the cow is also pulling up on the Earth? So not only is the Earth pulling down on the cow is pulling up on the Earth, but the Earth has a greater pull. So that's why the cow ultimately falls down. So go ahead and put this in our notes, please. Gravitational pull. Gravitational force occurs when two bodies physically attract each other by pulling. So again, the Earth is pulling down on the cow and the cow is pulling up on the Earth, but the Earth has the greater pull and that is why the cow falls down. All right, moving on. So this same concept happens in space. So gravitational force is also why the moon does not move away from Earth, but revolve and goes around it, okay? So the moon, okay, revolves and goes around Earth because the Earth is having a pull on the moon and the moon is having a pull on the earth. Okay, so it's constantly revolving around it because of gravity. Okay, they have that attraction to each other that pulls each other the different ways. So go ahead. Gravitational force is also why the moon does not move away from Earth, but revolves and goes around it. So with that, we want to kind of think about the cow example and the apple example. So if we think about that in relationship to the moon and the earth, many of us might ask the question, well, why doesn't the moon fall into the earth then? And the answer is it's actually constantly falling towards earth, but we know it never hits it. Well, why? That's something that we're going to be able to answer later as we go through and learn more about gravity. So as far as what you need to know as far as space, okay, it's why gravitational force is why the moon does not move away from Earth, but it constantly revolves around it. Now, there was a bunch of philosophers who first studied gravity, and the very first philosopher who studied it was called Aristotle. So Aristotle was a great philosopher in ancient Greek who wrote about philosophy, science, logic, poetry, politics, and many other things. So he's pretty smart. He knew a lot. Okay. In 350 BC, he wrote about physics and specifically gravity. So, but unlike, and this is important, unlike scientists of today, he performed no experiments and made no measurements. All he did was observe the world around him and wrote down his thoughts. So go ahead and put this down in our notes, please. Aristotle. And unlike scientists of today, he performed no experiments and made no measurements. He only observed the world around him and wrote down his thoughts. So he actually didn't do any type of experiments whatsoever. He just watched and wrote down what he saw. So why, guys, would this not be a good way of doing science? So think about that. If you're just performing no experiments at all and making no measurements and just watching, why would this be not a good way of doing science? All right, moving on. So what were his observations? Because as we saw, he never really experimented, he just watched. So observation, of course, is one of the first steps of doing science. We need to observe something. Thinking of why the world works like it does is next. Next, you have to actually measure what is happening and predict something new based on the measurements and experiments. So this is the only way you're going to know if your thoughts actually describe the world. If you don't actually do any type of experiments, guys, you're not going to know if what you think is correct. You have to actually test it. Okay. So the actual experiments lead to discovery of new things. Okay. All that Aristotle did was he just watched. So really, he didn't discover anything new because he never really tried it. So Aristotle was interested in how the mass of an object affected how fast it fell. He observed that heavier objects fell faster than lighter objects. So when a feather and a rock were dropped from the same height, the rock is going to hit first. Well, why? Well, so why would Aristotle say that the rock would hit first? Well, obviously we know that a rock is heavier than a feather. So Aristotle's observation was that if something weighs more, it's going to fall faster. So go ahead and put this down, please. Properties of gravity. Aristotle was interested in how the mass of an object affected how fast it fell. He observed that heavier objects fell faster than lighter objects. So again, we have that rock and that feather. If you drop them both at the same time, he said the rock's going to hit the ground first because it's heavier. And he didn't actually try it because, again, he didn't do any experiments. Okay. So ultimately, when people started doing experiments, he was proven wrong. Okay, that was not the reason that the rock hits the ground first. Go ahead and add this last part into our notes. Aristotle did not carry out any further experiments, and it wasn't until the end of the 16th century that people did do experiments and proved Aristotle wrong. So the big thing that you need to know about Aristotle, guys, is he only observed. He performed no experiments whatsoever. And because of that, his original observation was incorrect, okay? Remember, he observed that heavier objects fell faster than lighter ones because they weighed more, okay? That was not the case. All right, moving on. So tomorrow, guys, we'll get into this other scientist, Galileo, who actually performed the experiments and figured out why the rock fell faster than the feather. Okay, it had nothing to do with the rock's actual mass. Okay, and Galileo is going to be different than Aristotle because Galileo is actually going to do experiments where Aristotle did not. All right, guys, so that's it for today. Hope that this video was helpful, and I'll see you guys later. Bye.